Alright guys, so this video is going over pages 46 to 50 of the review from the Unit 2 Topic 2 packet in preparation for the Unit 2 test on Friday. I'll go quickly through these solution pages because first of all you can pause, but second of all you can, I will be posting a separate document with just the answers so you can reference those as well. Okay, so this is 13 through 14. 15, 16, and 17. 18 through 23. 24 through 27. 28 through 30. Alright, so now I'm going to go ahead and go through all of the problems in detail. Again, feel free to skip around, pause, whatever you need to do. So for number 13, this is rewriting each logarithm in exponential form. As a reminder, if you have log base b of y that's equal to x, that is the same thing as b to the x power is equal to y, and we can write that interchangeably. So we can go from here to here, or vice versa from here to here, and that's what we'll do in number 14. So for 13, we've got log base 8 of 1 over 64 equals negative 2. That turns into 8 to the negative second power is 1 over 64. B, ln of e is 1. Remember, ln is our natural logarithm. It is log base e, which means that the base here is e. This is our exponent 1, and then the y is e. Log of 1 is 0 for letter C. There is no base, and it's a log, not ln. The base is 10. The exponent is 0, and then the y is 1. For D, log base 5 of 125 equals 3. That's 5 to the third power is 125. Log base 8 of 2 is 1/3. That is 8 to the 1/3 power is 2. Log base 3 of 1 over 27 is negative 3. That's 3 to the negative third is 1 over 27. Log base 4 of 16 is 2. That is 4 squared equals 16. Log base 3 of 81 is 4. That's 3 to the fourth is 81. And log base 2 of 1 is 0. That's 2 to the 0 is 1. All of those are also true statements, both in the logarithmic form as well as in the exponential form. They're all true. You're going to use that exact same idea that we had here for number 13. For number 14, we're just going in the other direction. So the base, the exponent, and then that will be the y. So 6 squared equals 36 turns into log base 6 of 36 is 2. Remember, it's an exponent. You want to think of logarithms as what power functions. The answer is the power, or the exponent. 4 to the 1/2 is 2. That is log base 4 of 2 is 1/2. 9 cubed is 729. That is log base 9 of 729 is 3. Here, the x is actually an x. So log base 3 of 5 is x. This is not something to be able to calculate without change of base formula or estimation. For letter E, 2 to the negative fifth is 1 over 32. That's log base 2 of 1 over 32 is negative 5. Here, 9 to the negative first is 1/9. Log base 9 of 1/9 is negative 1. Here, e to the 0 is 1. Remember, it's base e. That means the log is ln. That is log base e. So ln of 1 is 0. 10 to the negative second power is 1 over 100. When it's base 10, we don't need to write that, so just log of 1 over 100 is negative 2. And then finally, 9 to the 1/2 is 3. That is the same thing as log base 9 of 3 equals 1/2. All right, number 15, this is one of the last things that we talked about. So it says given log of 3 is A and log of 4 is B, find the following in terms of A and B. So what you want to do there is you want to, first of all, we know that log of 3 and log of 4, they both have base 10. It's not something we're able to find without this information. But we know things about it. So for example, log of 12, well, 12 is the same thing as 3 times 4. And we know our expanding rules. If we have two or more arguments multiplied, or values multiplied in the inside of an argument, the inside of a logarithm, then we can break those apart and add them together. So log of 3 times 4 is log of 3 plus log of 4, and then log of 3 is A, log of 4 is B, so log of 3 plus log of 4 is A plus B. Same idea here for letter B. 4 times 4 is how we get 16. You could also have this be 4 squared and then expand that way. Like you'll see in letter D, you'll get the same answer. But here I just broke this down into log of 4 plus log of 4, which is B plus B, which is 2B. Get the same thing if you made it 4 squared, move the 2 in front, and then got 2B that way. Log of 3 divided by 4, log of 3 minus log of 4, that is A minus B. And then finally, and there's a couple different ways to do letter D, but one of the ways is to recognize that 1/9 is 3 to the negative second power, because 3 squared is 9, and then because it's a 1 over 9, that's what makes that exponent negative. Then what you're going to do is you're going to take this negative 2, you're going to bring it out front because you're expanding, and that's how this becomes negative 2 log of 3. Log of 3 is A, so negative 2A. So that's 15. 16 is just evaluating. We did some of this in the other video with the warm-up. This is just saying log base 2 of 4 is saying 2 to what power is 4? The answer is 2. Here, 2 to what power is 32? That's 5. 8 to what power is 64? That's 2. Here, if it didn't have the negative, then still we wouldn't be able to evaluate this by hand because I don't know what 3 to what power is 100. It's not an integer, but because this is a negative here, it doesn't even matter because we can't ever take a logarithm of a negative number or a 0. So since this is negative 100, that means that logarithm does not exist. Here, log base 7 of 1. This is saying 7 to what power is 1? Remember, anything to the 0 power is 1. The answer here is 0. Log base 8 of 1/8. 8 to what power is 1/8? Remember, it's a fraction, so we flip it. Only one of them is a fraction, which means we make it negative. Of course, 8 to the first power is 8. 1 over 8, that's going to be negative 1. 3 to what power is 27? That's 3. E and H are very similar. 4 to what power is 1? That's again 0. 3 to what power is 81? That's 4. 8 to what power is 2? This one's a little bit tricky. If they were reversed, it would be 3. 2 to the third power is 8. But because the base is 8 and then the argument is 2, that means we're actually going to take a cube root, not a third power, but a cube root. Cube root of 8 is 2. Cube root is the same thing as the 1/3 power. Okay? For letter K, what you want to do here is you can just cancel the log base 5 and 5. Otherwise, you move the 2/3 to the front, and then log base 5 of 5 is 1. So this is 2/3 times 1, which is 2/3. Okay? Or again, you can just cancel the log base 5 and 5 because they are the same. Letter L is similar to letter D. Again, you cannot have a negative here. If this were a positive, the answer would be 0 because 6 to the 0 power is positive 1. If it's not negative 1, we can't have a negative argument, so this does not exist. All right, for 17, here we're going to practice our canceling. So 7 log base 7 of x. The 7 and the log base 7 are inverses. They cancel. 27 to the log base 27 of x. Again, those cancel, so we're left with x. Same exact thing for 13. 13 to the log base 13 of x. The 13 and the log base 13 cancel. And again, we simplify to x. We can't do that here with letter D. We need to take the x and we need to move it in front. think we actually saw this one yesterday in our warm-up, if not exactly this, a similar one. You move the x to the front, and then log base 3 of 27, that's 3. So that's how we got 3x. We can't cancel this. We have to use our expanding because these are not the same. Unlike letter E, where you have log base 15 of 15 to the x, and then you can cancel, and that's x. But again, letter F, you need to move that x to the front. Log base 2 of 16 is 4. X times 4 is 4x. Okay, on to the next. The section here, 18, 19, and 20, it says which is equal to, and then there are 3 different problems. All 3 of these use the change of base formula with the natural logarithm. Remember, the change of base formula is if you have, with a natural, not the natural logarithm, I'm sorry, common logarithm, that's my mistake, common logarithm. Natural logarithm is ln. These are common logarithms, so it's log. So if we have log base b of a, that is the same thing as log of a divided by log of b. Make sure the order here is correct. The base goes in the denominator, the argument goes in the numerator. So log of 30 over log of 6, that's going to be log of base 6 of 30, that's b. Log of 24 over log of 8, that's log base 8 of 24, that's c. And log of 20 over log of 5, that is log base 5 of 20, that is b. Okay. 21, rewrite using the common logarithm change of base. So remember, common logarithm is just log. That's what we literally just did. So we're just going in the other direction. So as opposed to here, where we took this version and changed it to this version, here we're changing this version to that version. So we're going to go log base 2 of 7, that is log of 7 divided by log of 2. If you want to put the 7 and the 2 in parentheses, you can. It's fine either way. Ln of 5, rewriting with change of base with the common logarithm. Remember, ln is log base e. So this is the same thing as saying log base e of 5. So this is log of 5 divided by log of e. Not log base e, log of the argument e. Now, 22 says rewrite using the natural logarithm change of base. I put the change of base formula for the natural logarithm at the bottom. It's exactly the same thing, except for ln instead of log. So here we have log base 3 of y. That is the same thing as ln of y over ln of 3. And then remember, if there is no base, that means base 10. So log of 25 is ln of 25 over ln of 10. All right. Number 23 says to simplify by expanding and condensing. So you won't have to show both on the test. It'll be an either or situation. You can choose whatever you're most comfortable with for pretty much all of them. But this is just to show you multiple ways to do this. So first thing I did, regardless of which method I'm going to use, is I factored. So I got x squared plus 3x minus 10, and that factored into x plus 5 times x minus 2. With the expanding, I recognized that the x plus 5 and the x minus 2 were multiplied in the argument, which means they can be broken apart, and 2 different logarithms with those in the arguments could be added together. So that's how I got log base 3 of x plus 5 plus log base 3 of x minus 2. And then we still have this minus log base 3 of x plus 5. So then here we have a positive log base 3 of x plus 5. Here we have a negative log base 3 of x plus 5. Those can cancel. And then we are left with log base 3 of x minus 2. A different way to do this would be to condense. I see the subtraction sign here, which means that this argument can go into the denominator, since they're all the same base. So the condensing version goes from here to here, log base 3 of x plus 5 times x minus 2 divided by x plus 5. Then, because we have the same factor x plus 5 in the numerator and denominator, those can cancel, And we get the exact same answer of log base 3 of x minus 2. And although we did different methods here, it's the same problem, so the fact that we got the same answer makes perfect sense. All right, letter B. Um, I took the first step initiative the same way. I factored this x squared plus 3x minus 4 into x plus 4 and x minus 1. These should really be on one line. I just ran out of room, like you see here. So for expanding, I again broke these apart and added them. So that's how I got log base 6 of x plus 4 plus log base 6 of x minus 1. And then these were already there, minus log base 6 of x minus 5, minus log base 6 of x plus 4. Then I canceled the positive and negative versions of log base 6 of x plus 4 to get log base 6 of x minus 1 minus log base 6 of x minus 5. Condensing is similar. Both of these are subtracting, which means they both go in the denominator, not just the first one. This also goes in the denominator, so that's how we get log base 6 of x plus 4 times x minus 1 divided by x minus 5 times x plus 4. Then again, like 23a, the x plus 4's here, since it's the same factor in the numerator and denominator, can cancel. Okay, and so we get log base 6 of x minus 1 over x minus 5. Now, I know that these look a little bit different, but they're really not, because if I were to condense this, I would get this. If I were to expand this, I would get this. So they really are the same thing. Alright, then for 24, I have expand using the properties of logarithms. The key thing here for this expansion is to remember that the 2 is separate than the x cubed. So the 2 here is being multiplied by the x cubed, remembering, of course, that any exponent when we're expanding gets moved to the front and multiplied. So this is ln of 2 plus, because we multiplied, 3, because that was an exponent, ln of x, and then minus, because the y squared was in the denominator, 2 moves to the front as an exponent, ln of y. For letter B, what you want to do here is you want to take this 2 and move it to the front for expanding. So that's how I got 2 log base 2 of 5x. And then that 5 times x, that should be expanded as well. So we get 2 log base 2 of 5 plus, because 5 and x are multiplied, 2 log base 2 of x. You can also, if you want, make this 2 times log base 2 of 5 plus log base 2 of x. That would also be the same thing. Okay? You don't have to have it be distributed. All right, 25 is the same as 24, but in the other direction. Any numbers that are in front become exponents, and then adding is multiplying, or in the numerator, subtracting is in the denominator. So here we've got log base 4 squared, the 2 becomes an exponent, plus, turns into times, x to the third power, the 3 becomes an exponent, minus, so that goes to the denominator, y to the fifth, the 5 became an exponent. Now, it didn't say you had to simplify. If it did, you would make 4 squared into 16. It's okay to do that. It's not necessary. Either one of these would be full and complete answer. Notice for letter B that you've got 2 subtractions. That means that we have the x to the 1/3 is in the numerator, and then we have the log of y, the y, and then the z to the 4th. See how they're both subtraction here? That means that they are both in the denominator. So they are multiplied, but in the denominator. Anytime you're subtracting here, those go into the denominator. Okay, so that's 25. All right, these are labeled wrong. It should be 26 and 27, but I'll just go through them. So it says, given the graphs and the equations below, state the following required properties. So we've got f of x is log base 3 of 9x. So first of all, I'm going to go ahead and expand that into log base 3 of 9 plus log base 3 of x. And then log base 3 of 9, we can evaluate that, and that is 2. So this is 2 plus log base 3 of x. Okay? So just can be helpful because it asks down here for the equivalent equation. This 2 plus log base 3 of x, that's what I'm talking about when I say the equivalent equation. Okay? Now, the domain, the range, and the asymptote. Now, the asymptote here, because we're not moving left or right from the original parent function of log base 3 of x, the vertical asymptote is here on the y-axis, which is x equals 0. The domain for every logarithmic function is based upon the asymptote. So since the asymptote is x equals 0, the domain is 0 to infinity. Notice how we have parentheses because we should not be touching the asymptote, so that 0 is not included. So that's why that is a parentheses. Then for the range, regardless of what type, what asymptote we have, it doesn't matter. If you have a logarithmic function, you have a range of all real numbers, negative infinity to infinity. All right, then the x-intercept here, we have 190. Now, how did I get that? The x-intercept is always written a number, comma, 0. The x-intercept is the place where the graph hits the x-axis, which means the y value there must be 0. So what I did is I took, and you can use the equivalent equation or you can use the original equation, it's fine either way. What I did is I went ahead and set that original equation equal to 0, and I'm going to solve for x. So what I've been doing here, I've got 0 equals log base 3 of 9x, and then I know to get rid of this log base 3, because I'm trying to get to this 9x, this argument, I'm going to need to drop a base of 3 on each side. Okay, I'm going to exponentiate. So therefore, when I do that, I get 3 to the 0 power equals, and then now the 3 and the log base 3 are inverses, so they cancel, and that's 9x. 3 to the 0 power is 1, anything to the 0 is 1, and then just divide both sides by 9. So that is how I get 1/9 is the x value there. Okay, so that's the x-intercept. And then the last question here says transformation from the parent function. So really you're going based off of the equivalent equation here. Because we had the parent function is log base 3 of x, the parent function is going to be the logarithm with just x as the argument, but with that same base. We're looking at how did it change, and in this case, we've added 2, which means we are going up 2 units. If we add, we go up, as long as it's on the outside, not in the argument. And if we subtract, we go down, and that's what we're going to see in the next one, number 27. But in this case, we've added 2 to that parent function, so we are going to go up 2 units. I wrote translated, you can write shifted, but it is the key thing here is that it's up 2 units. Now, number 27, there's a lot of similarities here. First of all, again, you're given your graph, but notice, of course, the argument is different and the base is different. But if you look at the asymptote, we haven't added or subtracted anything in the argument, which means that asymptote is still on the y-axis, or x equals 0. So our domain is still 0 to infinity, and of course our range, irregardless, would be negative infinity to infinity. Then to find that x-intercept, I filled this out the same way. I said, okay, I'm going to say 0 is equal to my function. Since this is a log base 2, I'm going to exponentiate or drop a base of 2 on each side. So that way these will cancel. I get 2 to the 0, which is 1. 1 equals x over 16. And then I need to get rid of this 16 in the denominator, so I'm going to multiply each side by 16. 16 times 1 is 16. So that is how I get my x-intercept of 16, 0. Alright, for the equivalent equation, I did this the same way I did the first one. I expanded. So in this case, for number 26, the 9 and the x are being multiplied. That's why I expanded and added. Here, the x and the 16 are being divided. So I'm going to expand, but instead of adding, I'm going to subtract. And then I can evaluate just like I did before. So log base 2 of x stays, but then log base 2 of 16 evaluates to 4. So that's how I got the log base 2 of x minus 4, which is my equivalent equation. And then for my transformation, because we've subtracted 4, that means we're going down 5 units. So again, here, because I've added 2, that was up 2 units. Here, minus 4, down. Oh, sorry, there's a typo there. It should have been down 4 units. Down 4 units. I apologize. Subtracting 4, so I went down 4. Okay. Alright, so for 28, we're finding the inverse. The first thing you want to do when you're finding your inverse is you want to switch x and y. Remember, f of x is the same thing as y. So when I switch, I get x equals 3 log base 2 of y minus 6. Then I need to isolate my logarithm. So I'm going to first add 6 to each side. That's what I did to get to the second line. Then I divide each side by 3. That's how I got here. Then, now that I have that log base 2 of y by itself, I'm going to exponentiate or drop a base of 2 on each side, okay? And then these will cancel, and that is how I get 2 to the x plus 6 divided by 3. This again now becomes an exponent, and that is y, or f inverse. The little negative one is the inverse symbol of x. All right, for letter B, again, we want to switch x and y. So we have x equals 5 to the y plus 2 plus 1. And then we need to isolate the exponential function. The exponential function here is 5 to the y plus 2. So first I subtracted 1 from each side. Then, to get rid of the exponential base of 5, I took the log base 5 of each side. So on the left, that turned into log base 5 of x minus 1. And on the right, the log base 5 and the exponential base of 5 canceled to equal y plus 2. Then finally, I needed to get y by itself, so I subtracted 2 from each side. That's how I got my final answer. Log base 5 of x minus 1 minus 2 equals g inverse of x. Letter C, we have, again, switching x and y. X equals log base 3 of y plus 7 minus 2. Isolating the logarithmic function, we add 2 to each side. Then to get rid of the log base 3 here, we exponentiate or drop a base of 3 on each side, which on the left-hand side has 3 to the x plus 2 power. And on the right-hand side, the 3 and the log base 3 cancel, and we get y plus 7. Then we finally need to subtract 7 from each side. So that is how I got 3 to the x plus 2 minus 7 equals y, which rewriting it in proper inverse notation is f inverse of x is 3 to the x plus 2 minus 7. For letter D, we are again going to switch x and y. X equals e to the y minus 5 power plus 2. We need to isolate the exponential, which is the e to the y minus 5, so we subtract 2 from each side. Then we are going to get rid of the exponential base of e by doing the inverse, which is ln of each side. So ln of x minus 2 equals ln of e to the y minus 5. The ln and e on the right are inverses, they cancel, so we get ln of x minus 2 equals y minus 5. Then to solve for y, we add 5 to each side. And then to put it in inverse notation, g inverse of x is ln of x minus 2 plus 5. Alright, and then for the last two, so for number 29, You are looking to buy a car worth $30,000. You go to a bank to get a loan, and they suggest an interest rate of 2% over a period of 8 years. So create a model to help you determine how much you will pay in total for the car. So Y is going to be the total amount you're going to pay. The initial amount is $30,000. And then it's 1 plus 0.02. The 0.02 is the interest rate, raised to the t power. T is the time in years. So you could actually put in any time here, or any number of years, and you would be able to use this interest rate to find out how much you would pay in total. Then letter B, based on this model, how much will you have paid for the car after 8 years? Now, I did use a calculator to do this, but please keep in mind that the test is no calculator, so you will get problems that you'll be able to do without a calculator. So what I did is I did 30,000 times 1.02, again, that I just got from adding 1 to the 0.02 here. I'll raise that to the 8th power. I put that into my calculator, and that is how I got $35,149.78. All right, last one. A scientist is measuring bacteria growth in a petri dish. On day 0, it's the first day, there are 2 bacteria, and she measures the growth according to this formula. B equals 2 times 3 raised to the t over 4 power, where B is the number of bacteria and t is the time, measuring in days. Part A, how many bacteria are present after 4 days? So t is 4, so it's going to be B equals 2 times 3 to the 4 over 4 power. 4 over 4 is 1, so this is 2 times 3 to the first. Remember, you've got to do 3 to the first first. 4 multiplied by 2, 2 times 3, that is 6. Notice my word problem I have, units. I did the same thing for letter B in 29. That dollar symbol is my units. I could have also written dollars, but I need to do one of those things because I need to have units for word problems. In letter B, how many bacteria are present after 16 days? It's the same thing, except for you substitute 16 in for t, and then it would have been 16 divided by 4 is 4, so 2 times 3 to the 4th, we do 3 to the 4th first, PEMDAS, it's 81, 2 times 81 is 162, so 162 bacteria. Now, a problem that I'm not seeing in this review section, but you should be able to do as well, is with context, doing something like if I were to give you B and ask you for the time. So you would solve that just like you would solve any other exponential equation, like the problems that we did, for example, on pages like 44 or 45, problems like that, where you would solve for the exponent. So you should be able to do that in the context of a word problem as well. Okay? All right, guys, I will post the full answer key. Hopefully this is helpful. Thanks for being patient. Bye.